In this video, I'm going to go through some more examples of how to find domain given a function equation. So example 7 here, we've got f of x is equal to the fraction x plus 5 over the absolute value of x minus 1. And things I want to focus on are basically just the denominator. There's no square roots in this problem, but there is a fraction, so the denominator causes me grief. And so what I want to talk about is the fact that this denominator cannot equal 0. So what I want to think about is what value, when I put it in here, would make this expression, when I take its absolute value, equal to 0. And the only way to make it 0 is if x is equal to 1, right? 1 minus 1, 0, absolute value 0, 0. So x cannot equal 1. It's the only thing that it matters. Numerator, x can equal anything. All right, there's no restrictions on it because it's simply the expression x plus 5. So what does our interval notation look like? Well, you're going to go negative infinity to 1, throw that 1 out of the domain, and then from 1 to infinity, you pick back up. So when you want to remove a number from the domain, you need to absolutely use the parentheses, because that's telling me from negative infinity, I'm getting really, really close to 1, approaching from 0. And then basically I bounce over 1, so it's basically thinking about like 1.00001, right? A very, very tiny value beyond 1, but that's okay, it works, all the way up to positive infinity. So every number in the whole wide world works except 1, and we've thrown that out of domain. So I'm going to slide over to example 8. I'm just going to pinch in and pinch out. And problem number 8's basically a big mess. All right, we've got a square root in the numerator, and we have a denominator to deal with. So I need to take care of both of these. So numerator-wise, square root. I'm going to take the expression x minus 4, and because of the square root, I'm going to talk about that greater than or equal to 0. All right, greater than 0 means the expression has to be positive. So that means if I take the square root of a positive number, that's okay. It might be a decimal, but it's still an okay value. It's a real number. And if we have equal to 0, that means when I take the square root, it literally equals 0. And sometimes that's okay with these problems, sometimes it's not. In this case, because the square root is in the numerator, it is totally okay to have equal to 0. So if I do a little solving here, I'm going to say that x is greater than or equal to 4. All right, so now that that piece is done, I'm going to leave that off to the side. All right, I'm just going to be okay with it being there. I'll get back to it. And separately, I am going to look at this denominator of x squared minus 25. So first thing, let's try and give it a factor here. So x minus 5, x plus 5, which means when I were to solve these, remember each factor is a separate value, and each factor cannot equal 0. So x cannot equal 5, and x cannot equal negative 5. If I put positive 5 into this first factor, 5 minus 5 is 0. Nope, can't have that happen. If I put negative 5 into this second factor, negative 5 and 5 makes 0. Again, 0 in the denominator just causes all sorts of problems. We don't want to deal with it. So now what I want to do is combine these two different pieces of information. So I have this inequality here, x is greater than or equal to 4, and I have these two individual values that I need to throw out. So on my number line, I'm going to label negative 5. I have to throw negative 5 out of my domain. I'm going to label 4, and I know that x has to be greater than or equal to 4. And you'll notice I use the bracket there. That's the equal to part of the expression. Inequality. And then I'm going to go from, there's 5, and at 5 I need to throw out. So the interesting thing that happens here is this inequality says that I can't use any value less than 4. Like none of these values down here matter. So this piece, this -5, I don't even have to worry about. It's already been excluded by this inequality. So really, if you look at where the shading starts is at 4, and then the shading moves up to the right. So what's our interval here? We're going to go from 4 to 5, throw 5 out of the domain, and then from 5 to infinity. So 4 to 5, union 5 to infinity. Make sure all the parentheses and brackets are making sense in terms of which goes where. Okay, so that's problem number 8, or example 8. Let's see, I'll go with purple, and we'll do example number 9. All right, same idea here. I keep overloading these problems, but they're pretty good examples. We have a square root in the numerator, so expression for the square root, greater than or equal to 0. The equal to part totally is fine because the expression is in the numerator. So x is greater than or equal to -2, so that part's good. Separately, I want to focus on the denominator. So I've got the absolute value of x minus 5 cannot equal 0. So think to yourself, what value, when you put it in this expression, would create a 0 for you? And there's only one value there. That's the x is 5. All right, so x cannot equal 5. The number line for me is just a great way to organize these very different pieces of information. So on my number line, I have a -2, and it says x is greater than or equal to -2. So greater than or equal to, I'm going to put the brackets, right, and shade greater than is going to be to the right. And then I've got x is not equal to 5. So as I'm moving up my number line from -2, right, moving towards infinity, at some point over here, I'm going to hit 5. And when I get to 5, I'm going to throw it out of the domain. Okay, it's that simple. It is not welcome in this domain because if 5 is in the domain, we're trying to divide by 0, and we don't want to do that. So -2 to 5, union 5 to infinity. All right, so this is a nice combination problem, but deal with the parts separately, right? Take a look at your numerator. Take a look at the denominator. Look for any of those square roots. The absolute value isn't really causing any grief other than to look at the denominator as an issue, but if the absolute value were in the numerator, it wouldn't be an issue. Okay.